First, remember the format for everything is do a few definitions, do an example that's already completed, another example where you fill in the blank, and then I'm going to have you guys try one on your own. Right? So, as we're doing this, be thinking, how am I going to be able to do this on my own? Please don't just look up, copy it down, write it. You know, you're not learning by doing that. You have to be thinking, how am I going to be able to do this by myself? Any questions you come up with, just ask them. So first thing I want to talk about is these definitions. Ratio, proportion. What are they? What do they do? Ratio. Ratio comparison of two numbers by division. So, is this a ratio?
Yeah.
Yeah. Is this a, what else does it look like? Fraction. So the first thing is, what is the difference between a fraction and a ratio? That's a great question for a quiz, because they both look like a fraction, but how they're used is what determines which one it really is. I'm going to use a baking example. If you're baking, a recipe might say add 1/4 cup to whatever, flour or something else. Right? That's a fraction, just a measurement. 1/4 cup. A ratio would be something like 2 eggs for every 3 cups of milk. That's a ratio. We can do a lot of things with this, but it seems we have two things going on. We have eggs and milk. Here we're just talking about 2 cups of something, 2 cups of just fine. Okay. So ratio lets us increase or decrease as needed. Let's say this is a part of a recipe for 4 people. We want to make it for 8 people. We can increase it. We can make it 4 eggs. So we're going to do 6 cups of milk. Okay. And that's how we use fractions and ratios. They're slightly different. So if you can come up with this example or something similar to this example on a quiz, that's perfect. So that's like one of those, after you solve all the problems, explainable. Alright. Now, what is a proportion? That's just when you have 2 ratios that are equal to each other. So proportion actually said one earlier. 2 eggs, 3 cups of milk. So if you want to double it, make it twice as big for twice as many people, it would be 4 eggs for 6 cups of milk. By the way, these are nothing but equivalent fractions. In a way, we're just reducing fractions. We're just like reducing fractions. Reduce 6 over 4 to get 2 over 3. But we might be going the other way. Fractions. So in a proportion, these are always equal to each other. You should be able to reduce one to get the other. Now sometimes you're going to have a decimal, it's not quite as easy, but I'm sure you have to do that with the calculator. Alright, go ahead and read this right here first. Let's try this example.
Projects class.
Now, after reading it, they give you a nice format of how to break it down. If later on, for any of the homework problems, you say, well, I don't even know where to start, this is where to start. You have A, B, C, D, and E, 5 steps that really break it down to smaller pieces. Sometimes reading all this, you're like, I have no idea. If you read part A, okay, write a ratio for a man's height. Okay, well, I can do that. I can see a picture. Okay, he's 6 feet tall. And to the totem pole's height. Okay, there's the totem pole. So I guess my 8 feet tall. Okay, I can do that. Okay, that wasn't so bad. Instead of reading everything and saying I'm totally confused, let's do one thing at a time. Notice how the first thing you read in the sentence is what goes on top. The second thing in the sentence is what's on the bottom. So man's shadow, that goes on top. Shadow is what we don't know. X. proportion, set these two to each other. You should note that, like on this, the way they said it up here, we have both the heights here, both the shadows here. Over here on the side, we have both the heights on, both measurements about the man on the top, both measurements about the people on the bottom. This has to be consistent for every problem. Now, these can be switched. If you put the pole's height and shadow on top and the man's height and the man's shadow on the bottom, it's still the same. It still works just fine. Likewise, if you put the shadows here and the height here, that's fine. So your proportions may not look exactly the same tomorrow when you check your answers, but if you get the same answer, you're all the same. Now it's a simple one-step equation. What divided by 45 equals 6 over 90? A couple ways of solving this. One way is just to divide both multiply both sides by 45. Right? So this is divided by 45. I'll do that by multiplying by 45. So step D is in solving. Use the different properties of quality, add to both sides, subtract to both sides, multiply, or divide. If you have a calculator, you can you can punch this in, or you might be able to see 45 goes into 90 2 times. 6 divided by 2 is 3. So not every problem with fraction requires a calculator. If you can see 45 goes into 90. When I see 45 and 90, I really think about down. 45 degree angle, 2 45 degree angles, 90 degree angles. Alright, so let's begin to end with one example. And we'll do one more and then have you guys try it on your own. This has to do with two objects casting a shadow. That's one type of problem you'll see. Another one has to do with scale drawings. Scale drawings. Just skip over here. Scale drawings. So it used to be, before GPS and smartphones and everything, you'd actually have a map that you would unfold. You could never fold back to the original way. And you'd have to actually measure on the map with a ruler to see how many miles something is from, like how many miles it is from one city to another. And there would be a key in the right-hand corner about, well, an inch on this map is really 18 miles. That way you can plan if you're doing a trip. Okay, here's what I need to fill up in gas because I'm going to get 400 miles, so I have to know when I'm going to run out of gas and make sure the gas station is close. A lot of different reasons for using this. So they'd say like 1 inch on a map on a piece of paper is really 18 miles per line. And we can go through and figure it out. And say, okay, if the map is 1 inch and actual is 18 miles, and I'm going to go 11.25 miles, notice how it's on the bottom because actual is on the bottom. How do I know if 11.2 goes on top or bottom? Good question. So is it the map or is it the actual? Which you want to look at. Right. And then we can solve it. Multiply both sides by 11.25. See how you need to use a calculator here. So again, very important to see either both map measurements have to be on top or on the bottom. Can't be. Let's give it a try. Actual distance between North Chicago and Keegan is 4 miles. What is the distance on the map? Okay, so is this an actual or is that a map? Actual. So let's go on the top or the bottom. Or scale. Oh, you know what? We're using the same scale from the last time. Yeah. What was it again? You guys can see it.
There was 1 inch.
There we go. Okay. So 118. And then, yeah, 4 miles is the actual. So it goes on the bottom scale. 4 miles. What is the distance on the map? So map is on top. Okay, that's what we're trying to find. There's our clue. Yep. We'll put the unit there. So the last time we had to multiply by 11.25 on both sides. So basically the number underneath the variable is what we're multiplying by. So same situation here. Number underneath the variable is 4. This means this is divided by 4, so it's undo by multiplying by 4. It gives the same stuff right here. 18, 4, 18 on the bottom. So, what is this distance? Go ahead and punch it in, see what you get. 0.2. 0.2. And then, of course, here we probably want to put inches, but it's also here. 0.2 inches. So does that make sense? Yeah, if 1 inch is 18 miles, 4 miles we expect to be less than an inch because it's a shorter distance. So if it goes down from here to here, from 18 to 4, you see how it gets lower. You expect to see that here. This number has to be less. 0.2 is less. Alright. Use this example to help you out. Think about how the map and the actual, something known as a scale. Scale on top and the actual on the bottom. Give that a shot. Scale on top. Actual on the bottom. Right. Of course, you can work with somebody next to you. You can pick another out. So after a little bit of prying and pulling, I convinced you guys to really follow other examples. Okay. Some of you started off here, scale over actual. The problem above, it was what, 1 over 18. What is the scale on this problem?
32.
Now, if you fail to even get this far, I wonder about your commitment. If the problem right above says scale 1 over 18, and then I say scale over actual, and it says the scale is 32 over 1, and you didn't write that down, it seems like there's a lack of effort there. That's not like, well, that's too hard to find out, or I couldn't get it, it's hard. It's like, maybe you're looking, and I've seen this a lot often in math, you want to look at just numbers. You see 192, 32, and 1, and you say, I don't know what to do. Reading the problem and understanding it makes a huge difference than just pulling out the numbers and trying to figure out what to add, divide, and multiply. So give that a shot. Understand the problem. All right, and it says the scale of the human heart is 192. Okay, so I know I'm doing proportion. Does the 192 go on the top or the bottom? Okay, so there you have it. We know scale goes on the top.
196.
Oh, that's right. In your books, it's 196. Let's use that. And we don't know, and the question lets us know how many inches is the actual. So it makes sense for the actual. That's where the variable is. And then we can go ahead and solve that. Now, when you have the variable on the bottom, here's a faster way of solving it. Cross multiply. So 32 times h, 32h. And then 1 times 196 is just 196. And then we can divide Answer comes out to 6.125. Is that the answer?
No.
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 We read the last part, says round your answer to the nearest whole number. So, is this the answer?
No.
Wait,
Yes. Like
Yeah.
inches.
So here's the whole number. Yeah,
You
that's
need to
it.
write inches in order.
All right. One more thing we need to fix. Do not use when we say round.
Wait, what?
Quiet, please. Hold still. Hold still. No. Stop. Don't move. Stay hold still. Hold still. Hold still. Yeah. So it says round. Right? Whenever it says round, make sure you use the approximate sign. Okay? Approximately 6 inches. And of course, put the inches. What is 6 inches? The heart. Length of the heart. So the size of the heart. So write that out. Size of human heart is 6 inches. Is that reasonable?
Yes.
Yes, it is.
Right? If that came out to 30, you'd know, well, the human heart, that wouldn't fit in our bodies.
That's a big
We're not talking about some random type of animal. We're talking about the human. That's you. So that should make sense to you.
Totally different.
All right.